In Algebra 2, Section 6-7, we're dealing with the remainder and factor theorem. And the first part of this lesson has to do with direct substitution. And basically what that means is when you see, and we've seen it before in the prior sections, whatever you see in here, you can replace it with the variable in there. That's basically all it's asking you. So what it's asking me to do here is to replace my 4's with all the x's. So my f of 4 looks like this. 3, here's an x, so I'm going to put 4 to the 4th, minus 2, here's another x to the 4th, plus, this is another x, 4 squared minus 2. And once I plug that in, I can just go ahead and do the math. Order of operation asks us to do exponents first. So we'll do 3 times 4 to the 4th, which is 4 times 4 is 16. 4 to the power of 4. 256. This is 256 minus 8 plus 4 times 4, which is 16 minus 2. So do the powers, and we're going to multiply these two. 3 times 256, 768. So this equals 768 minus 8 plus 16 minus 2. Now I know some of you guys don't want to put as many steps as this and you want to do shortcuts, but it's very important, again, that you keep your math as organized as possible and just take it step by step. Don't be afraid to overdo it with the steps, because if you make a mistake, then you can check your problem, or if you are stuck, then I can see in class what I can help you out with. So don't try to take too many shortcuts where you end up getting the wrong answer. Now from here, the order of operations wants us to add and subtract from left to right. So what we're going to do here is we're going to start with these and combine it. So 768 divided minus 8 is 760. Okay, plus 16 minus 2. Then when 760 plus 16 is 776 minus 2, and 776 minus 2 is 774. So this is in fact our answer. So there's another method in your book that you can use called the remainder theorem, but as long as you know how to use direct substitution, you're good. On the test, you're more than welcome to use the remainder theorem to solve the problem, but as long as you got the correct answer, whichever method you use, you're more than welcome. The next problem we're going to do, and the last one, so don't forget to pause that and write it down for your notes and your vocabulary as well. This is our last one, our last chart, and basically we're introducing to the factor theorem. Basically what the factor is, you remember how we were dividing polynomials? Remember you did synthetic substitution, long division? And what it's saying is basically, let's do, for example, you don't have to write this down on your notes, but if I want to say 16, if I ask you, is 4 a factor of 16, basically you can say yes. But the question is, why is 4 a factor of 16? Well, it means that if I divide 16 by 4, I get a whole number, which is 4, right? And the remainder is 0. Here's the key. That means that if I divide this equation into x minus 3 and my remainder is 0, then this is in fact a factor. If I don't get a 0, then it's not a factor. So the first step is to see if it is factor. So first I'm going to divide it. And then from there I'm going to find all the other factors of that. So we're doing what we usually do in your like when we're factoring whole numbers, which is 16 is 8 times 2, this is 4 times 2. So the factors of 16 is 4, 2, and 2. These are the factors of 16. So we're doing the same thing here, is basically we're factoring, but instead of a number, we're factoring the entire equation. So we want to find all of the bubbles that are involved when I multiply them all together to get this. And the first step is to figure out, in this question, is this one of the bubbles? Can I divide it by this? So let's show it. by first dividing. Now I'm going to use synthetic division. Okay, if you remember that. If you don't remember that, go back in your book and remind yourself what synthetic division is. Basically, I'm going to take this last number, but instead of -3, I'm going to do the opposite. Remember, you do the opposite of this. So I'm going to put 3, I'm going to put it in its own box. Okay, now I have 3, 2, 1, and x to the 0, so that means I have all my place. So that means I don't have to put a 0. Remember that if it goes from 3 all the way and didn't have an x squared and went straight here, I would have to put a 0 in place of x squared, if you remember that in synthetic division. So don't forget to do that if necessary. In this case, it's not necessary. I just need to take all the coefficients. Okay, and again, if you don't remember, there's a whole video that you can go back, you know, talking about synthetic division. I'm going to assume that you remember how to do it. So basically, we're going to take the coefficient. So the number in front of x cubed is 1. The number in front of x squared is 4. The number in front of x is -15 and -18. And what we're doing here is we're looking for what remainder? We're looking for remainder 0. If we get a remainder 0, then that means this is in fact a factor. So, let's multiply. I'm going to take this down, bring it straight down. I'm going to do 3 times 1 and put it under here, which is 3. And what do I do here? I'm going to add. So 4 plus 3 is 7. Okay? 7 times 3 is 21. 21 times, -15 plus 21 is 6. And then 6 times 3 is 18. -18 plus 18 is 0. So this means that when I write the answer, this is going to be, this is x to the cube, so I'm going to start with x squared. 1x squared, and I'm bringing this down to positive 7x plus 6, and remainder 0. So this is it, remainder 0. This is telling me that this is, yes, in fact, a factor. So what that means is, if I multiply this, that means if I put the number x minus 3 and I multiplied it by my answer here, I would get my original equation. But I'm not done because it's asking me to find the remaining factors. So that means that since this is an x squared, I can further break this down into even more bubbles, factor this and simplify it. So I know definitely x minus 3, but now I can take this and I can break it down to 2 bubbles. This number in front of x is 1, and remember we went over in class and in the previous videos. If there's only a number 1 in front, then I can just put 2 bubbles and I can focus on these numbers. If by chance there's like another number 2, 3, anything higher than a 1, then there's a whole different method that we have to go through, which we went over in class and the previous videos. So in this case, it's pretty simple for us. Again, when we're factoring this x squared, I'm looking for 2 numbers. When multiplied together, gets me the last number, but when added together, gets me 7. So I'm going to look at factors of 6. I know that 3 times 2 equals 6, but this added together gets me 5. There's 6 times 1. 6 times 1 is 6 plus 1 is 7. So these are our magic numbers. So x plus 6 and x plus 1. What this is telling me that if I boiled this out, and then once I got that answer and then distributed it into this one, if I multiplied all these 3 together, it would get me again the original factor. Okay? Sorry, not the remainder factor, but the original factor. So these bubbles are all the factors of this equation. And this is my answer. This part with the remainder 0 shows me that it is a factor, so that's the first part. And this right here, factoring this into these 2 bubbles and bringing this straight down, that tells me, this handles our second one, which is the remaining factors of that equation. So go ahead and pause it, write it down, and then go ahead and try page 359, number 4 and 6, 359, number 4 and 6, and I will see you in class.